Previously, we have discussed what electrophilic substitution reactions are. We have studied a model reaction of electrophilic substitution reaction, and we have studied the mechanism. So in this session, we are going to cover a real world example of electrophilic substitution reaction on benzene, and the reaction is going to be sulfonation. So in sulfonation, what happens is, over benzene, SO3H group is introduced. So this is electrophilic substitution because hydrogen has been replaced by an electrophile, which is SO3H. And this reaction is called sulfonation because introduction of sulfonic acid is being called sulfonation. Okay. So benzene is converted to benzene sulfonic acid. In this reaction, your concentrated sulfuric acid is being used. The acid itself is going to act as a reagent as well as it is acting as a catalyst, and the reaction is happening at 80 degrees Celsius. So the molecule itself is acting as a reagent and is acting as a catalyst. I have already told you the product, which is benzene sulfonic acid. So you have two choices in your hand. Either you can use concentrated sulfuric acid, otherwise you can use fuming sulfuric acid. Now these two things are two different things. Concentrated sulfuric acid is different and fuming sulfuric acid is different. Concentrated sulfuric acid simply means a solution which have high concentration of sulfuric acid, probably like up to 98%. This would be called concentrated sulfuric acid. Fuming sulfuric acid is H2SO4 dissolved with a gas with the name SO3. Sulfur trioxide when dissolved in sulfuric acid, and this solution is called fuming sulfuric acid. The correct name for fuming sulfuric acid is oleum. So you can see that concentrated sulfuric acid when mixed with sulfur trioxide becomes this, and this is nothing but your oleum, or you can also call it fuming sulfuric acid. So it's your choice. You can use concentrated sulfuric acid or you can use oleum to do this reaction. So the main thing here is going to be your generation of electrophile. So in the end, your electrophile is SO3. So either you are using oleum, then SO3 is always available. Otherwise, if you are using concentrated sulfuric acid, then SO3 has to be generated from the molecules of concentrated sulfuric acid. We will see this thing in the coming moments. So this was your model reaction. I hope you were able to understand this reaction, what sulfonation is. Now let us move on to the mechanism of sulfonation reaction. So the first step is what? As you can recall from the previous lesson, the first step is generation of an electrophile. So if you are using concentrated sulfuric acid, the two molecules of sulfuric acid would react to form sulfur trioxide, and the sulfur trioxide is going to act as our electrophile. Okay, so let us see. Here you can see one molecule of sulfuric acid is reacting with another molecule of sulfuric acid, and one molecule is acting as an acid and the other one is acting as a base. So this particular molecule of sulfuric acid is giving H plus ion, and this is receiving the H plus ion. So this is acting as a base and this is acting as an acid. So this will form this counter ion. This OH will have one more H as plus, so plus charge would come on oxygen and H will come, and over here H will go away and the negative charge would be placed over oxygen. So you can call it conjugate base because it has been formed from the acid. So this ion is conjugate base and this ion is conjugate acid because this has been formed from this molecule which has acted as a base. Now your conjugate acid is going to dissociate into two things. One thing is sulfur trioxide and the other thing is hydronium ion. Let us see how it is going to happen. The OH bond will break such that the two electrons of this bond will be shifted between oxygen and sulfur. So new double bond would be formed here because the two electrons from this place are going to get transferred between oxygen and sulfur, and this sulfur oxygen single bond is going to break such a way that this oxygen is going to get the two electrons of this bond. So this positive charge will neutralize. So H plus with this H2O will combine later on and form hydronium ion. because this has H plus has been re-attacking the water molecule and H3O positive has been formed, but from the middle the sulfur trioxide has been created and this will act as an electrophile. I hope the steps are clear, because this is going to be confusing for you if you have not practiced such things in past. But I will repeat it one more time for you, that the two molecules of sulfuric acid are acting with each other. One is acting as an acid molecule and the other is acting as a base molecule. This will form conjugate base and conjugate acid. The conjugate acid will dissociate to give sulfur trioxide and the hydronium ion. Now in the next step, the second step is going to be formation of carbocation intermediate. So benzene is going to attack on the electrophile. So the electrophile is sulfur trioxide. So pi bond will be utilized and the sulfur oxygen bond will break, so that negative charge comes on oxygen and a positive charge would be created on benzene. This step is going to be a slow step because aromatic molecule do not want to react to give non-aromatic molecules. Okay, you can show the resonance stabilized structures. Otherwise, you can write directly as hybrid. So this carbocation in the third step is going to lose a proton to give the final product. This is not actually the final product. We will see the final product in coming moments. From the carbocation, the conjugate base which was formed here, this conjugate base is going to assist the removal of this H as H plus ion. This hydrogen would be removed as H plus ion, as H positive charge. So the two electrons of this carbon hydrogen bond will be transferred to the benzene and positive charge would be neutralized. So the benzene would regain its aromaticity and this molecule of sulfuric acid have been regenerated. And now this step is going to be a fast step because non-aromatic molecule is getting converted to aromatic molecule. And the final step is going to be the addition of proton to the ion intermediate. Do not call it carbocation intermediate, but call it ion intermediate. So the water hydronium ion from this place will come and give this SO3 negative, the H plus ion. So positive and the H will be transferred over here. So this negative charge would neutralize and the water molecule would be formed. So you can finally see that your final product has been formed and the water molecule has been formed. So overall, one sulfuric acid molecule has been consumed to give sulfonic acid on benzene and the water molecule. So this was your sulfonation reaction. I hope you were able to, read it out, that this is the sulfonation reaction and all the elementary steps of the mechanism has been discussed. So this way we are going to cover all the reactions of electrophilic substitution reaction of benzene. So next reaction is going to be nitration. So see you in the next session.